Your major is networking or programming. You need to know about the language of the computer, which is bunch of ones and zeros. Ones and zeros. That's the language of the computer. Everything, those of you in programming, you know, we start with binary, then assembly language, then higher level languages, stuff like that. Okay? Ones and zero is what we're going to talk about today for about a few minutes. Okay? So ones and zero are known as binary, or what we call number system. So this slide 1 is going to talk about decimal, which we use every day, which is base 10 that we use every day. I will try to convert it to binary, which is the language of the computer, ones and zeros. Okay, so that's why we will start. Decimal to binary. So let's just pick up any number randomly in decimal. I'm just making this out. Suppose we have 107 decimal. So the key is that how can we take it to a bunch of ones and zero, which is base 2 or binary. So there are two methods to do this. One is the division method. The other is the subtraction method. Okay, if you go to the library, any book in computer science, it will tell you all this. So we don't have to waste time. The better of the two is subtraction method. So subtraction method says that line up all your ones and two, your base 2, powers of 2. Know your powers of 2s. 2 to 0, 2 to 1, 2 to 2, 2 to 3, 2 to 4, 2 to 5, 2 to 6, 2 to 7, and you can make it as big as you want. Okay? Once you know your powers of 2, which is 2 raised to 0 is 1, 2 raised to 1 is 2, then it keeps doubling itself. Okay? So these are the powers of 2s. You say, well, whatever number, this what we have 107, we're going to start subtracting the highest. And the one we are going to use, we put 1 under them. Means 1 is there. 1 means on or true, is present. 0 means off or false. Okay, so we're going to bring back the 107 in slide 2. So I gave you 107 base 10. Let's take it to base 2. So I line up my powers of 2. So I know that we have enough. Okay, so I will take 107. What's the highest power I can deduct from it? 64. You see, we use 64, so I put 1 under it. Okay, what do we have left? We have 343. Okay, so we have to subtract 32. So we put 1 under 32. We have 1, we have 11. Then we subtract 8. We're going to, until we reduce it to 0, we're going to keep doing this. We have 3, then we use 2. Then we have 1. So we have reduced it to 0 now, and we have been able to use all these numbers. The one that we skip, we write 0 under them. Okay? So this big number now, so I'll go to slide 3 so you can see. Let me write on the side here so you don't get. So this 107 base 10 becomes, you read them, 110 1011 base 2. 1 1, you have to be careful, you double check. 0 1 0 1 1. So we have gotten this number now. So it's very easy to take any number from decimal to binary. Let me do one more. Okay, so let's go to slide 3 now and do one more just for briefly. Okay, so let's say this is let's make one a little bit bigger. Suppose we have 311, just making it up. Okay, base 10. What we do every day, let's take it to base 2. So we have the powers of 2's 1 2 4 8 16 32 64 128 256 512. You see, it can be as big as you want. So we have 311 now. The highest power we can take is 256. We use 256. You have to be careful about your arithmetic. 11 5 10 5. Okay, so you check again to make sure that the arithmetic is okay. Then we have 55. You see how we have reduced this big number to small numbers. Then I use 32. I have 23 left. Then I use 16. I have 7 left. Then 7 now. I use 4. I use 4 2 1. But let me do it really, if you don't mind, let me bring it right here. Okay, I use 4. So we're going to put the 1 down there, 4. Then I use 3. I have 3 left. I use 2. I have 1 left, so we use 2 and 1. See, we skip all this. So with this second example now, 311 in base 10 becomes 1 0 0 1 0 0 1 1 1 in base 2. So you can see it's very easy. In the next slide now, we're going to see how to take it back. So we will not just be making it up. Some people say, well, maybe we're going to make it up. So in the next slide now, we're going to see how we're going to take it back. So slide 4 says that, let's look at what we just gotten from slide 3. We got 1 0 0 1 0 0 1 1 1. Base 2, we want to take it to base 10, where we started from. Okay, so let me make sure we got the right thing. 1 0 0 1 0 0 1 1 1. Okay, this one says that if we're going to take it back, so this is binary to decimal. Okay, so with this now, all we need to do is just plug in the powers of 2's. Okay, 1, there's a little marker here. 1 2 4 8 16 32 64 128 256. Those are the powers of 2. I plug them on top of it, and I'm going to only add the one that are there. 256 is there, plus 32 is there, plus 4 is there, plus 2 is there, plus 1 in there. If our arithmetic is correct, we should get 311. So you can see that it's so easy to take from decimal to binary and binary to decimal.